Hi guys, Dr. B here. This is topic 1.2 for AP Chemistry Mass Spectra of Elements. The learning objective is to be able to explain the quantitative relationship between the mass spectrum of an element and the masses of the element's isotopes. A sample of a pure element contains a variety of isotopes, atoms with the same number of protons and electrons but different numbers of neutrons and therefore different mass numbers. The percentage of each atom with a specific atomic mass in the sample is that isotope's relative abundance. If we look at our example here, we have chromium and it has 4 naturally occurring isotopes. They're shown in the data table below. So notice how when we typically talk about chromium, the most abundant one is chromium 52. It is 83.79%. So we can expect that the average atomic mass should be somewhere around there. And if you look at the periodic table, it's like 52.00 or 51.99 something AMUs or atomic mass units. So part of this topic is you need to be able to either get the relative abundance or for each isotope or get the masses of each isotope or something along those lines. Mass spec or mass spectroscopy, you may have heard of this when we watched CSI before. It's an analytical chemistry lab technique that separates the components of a sample by their mass. The average atomic mass of an element can be calculated using the relative abundance and the mass of each naturally occurring isotope of that element using the following equation. The average atomic mass equals the sum of the relative abundance of the isotopes times the mass. So a lot of math with this one. The mass spectrum of a sample of a pure element is shown here. Calculate the average atomic mass. What is the identity of the element? So from our spectrum here, we can see that there are 3 isotopes and they have the following abundances. The mass of 39 AMUs is 93.26%. The mass of 40, it's a very small one, it's not even showing on there, is 0.01%, and the mass for 41 AMUs has 6.73%. All we're doing now is trying to find the average atomic mass. So the average atomic mass, because it kind of sucks putting all those things. So remember, it's the sum of the relative abundances times the mass of the isotope. So whenever we're doing this stuff right here, technically if it's in a percent, it needs to be in the decimal form for you to be able to calculate this out. What do I mean by that? Move the decimal over 2 to the left for each of these. 0.3926 times 39 AMU plus 0.0001 times 40 AMU plus 0.0673 times 41 AMU. You do your math. You end up with an average atomic mass of 39.1347 AMU. Ooh, what's supposed to be AMU, not whatever that is. What is the identity of this element? So you look at the periodic table, and whichever is the closest to it, hopefully it's done correctly, it's going to be potassium. So you can see a problem like this could maybe in the MCQ, but maybe in the FRQ as well. So be careful when you're doing this so you don't make the mistake of not moving your decimals over to the left like you're supposed to. Okay, so keep an eye out for that. Rhenium is one of the rarest elements on Earth. Alloys containing rhenium are used for oven filaments and X-ray machines. The average atomic mass is 186.21 AMUs. There are 2 common isotopes with the information given to you in the graph or the chart below, calculate the percent abundance of naturally occurring rhenium. So here we are trying to find what are the percent abundance for each of these. So we're going to use the same formula, but we're going to kind of use it differently. So the average atomic mass equals, like we said, the sum of the relative abundances times the mass of the isotope. So the average atomic mass, so 186.21 equals X times 184.95. The X is going to be the decimal form of the percent that we're going to use to find later on. Plus, so I'm going to preface this by saying this, Y equals 1 minus X. So 1 minus X times 186.96. One of the things that students tend to mess up on is they don't show enough work. One of the things when you do an FRQ, it says you need to show your work in order to get full credit. You can get the right answer but not show work, then you won't get the credit. When I say show work, basically if you have to calculate it in the calculator, put it in the calculator. Right? If you have to put it in the calculator, put it on your paper. Make sure you show the setup, because if you don't show the setup, that will mean you're not showing the work. So distribute the 1 minus X, get all likes, whatever, on the same side, whatever that means. Sorry. So I'm going to subtract 186.96 on both sides to get negative 0.75 equals negative 2.01x. Divide both sides by negative 2.01. X equals 0.373. That means the percent abundance for isotope 185 is going to be 37.3%. Y equals 1 minus X, so 1 minus 0.373, so 0.627 or 62.7%. All right, if you have any questions, please let me know. Thanks.